Hi everyone, welcome to Science Lab. Today we're going to learn about the sun, the electromagnetic spectrum. In the electromagnetic spectrum, there are many different waves. Radio waves for listening to AM radio, microwaves for cooking, infrared waves for night vision, seeing in the dark, visible light, the light that we see every day, ultraviolet, sunburn, X-rays, doctors use X-rays to see bones and teeth inside our body, and gamma rays. Gamma rays are also used in medicine for MRI. So let's get started. I'm back. Visible light is the one I want to talk about, the sunlight that we see. Visible light, we have the rainbow, the colors of the rainbow. Very beautiful. How do we see the colors of the rainbow? It's in all light. The colors in a straight line show white light, but when we bend light, we can see the colors, they separate because the colors have different lengths. So how can we bend the light? We can bend the light with a prism. When we bend the lights of different lengths will break down and turn into different lengths. So how do we see a rainbow? We see a rainbow, what acts as a prism? Raindrops. Raindrops are our prism. We also use diffraction grating for a prism. So we have a prism, diffraction grating, and raindrops bend light so we can see the colors of the rainbow. So these are some tools that we have to study light. We have diffraction grating for breaking down and bending light. We have lasers to see the beams of light. And we have another object that bends light, the prism. It acts like a diffraction grating, or I should say diffraction grating and prisms are pretty similar. One is flat and one is triangular. There's also another object that is good for bending light, and that's raindrops or water. Drops of water in clouds, when it rains and there's sun, breaks that sun and bends it, and then we can see the colors of the rainbow. So raindrops are nature's prisms. Next time you see a rainbow, you know what is bending the light. The raindrops are bending the light like a prism or diffraction grating, and we can see a pretty rainbow. So let's take a look at the gases using diffraction grating. The first gas is CO2. You can see a spectrum. Each gas has a unique spectrum. See the black lines? This gas is helium. I'm using a diffraction grating. Diffraction grating comes in an A4 sheet and I cut them apart for each student to use. The next gas is hydrogen. Hydrogen is pretty unique. So when we look at different lights with something that can break the light down to the spectrum, like diffraction grating, we can tell what the element is. This is hydrogen's fingerprint. The next gas is argon. Next, we have nitrogen. You can see those black lines between the gases or the colors. When those lines shift, move left or right, we call the lines when they go to the left a red shift. When they go to the right, a blue shift. We can tell if an object or a star is moving away from us or towards us by this method. This gas is neon. Maybe you've seen many neon lights shopping. Neon has a unique spectrum of lines and color thicknesses. When the lines shift to the left, we know a star is moving away from us, called a red shift. When it shifts to the right or the blue side, we say it's moving toward us. Red shift or blue shift. Lasers are pretty cool. They're intense beams of light. You can only see them when they touch their end point. It's fun to play with lasers. Very intense beam that goes very far. So to help us see the laser, we'll give some spray. Now the laser has something to be seen by. This is air freshener. It smells good. And when the smoke is cleared, we can only see the end point. A little lower, there's more smoke. Up higher? No. One more blast. Lasers can go quite far. Way on the back wall on the picture. There they are. Now on the seats. Maybe there's still some gas over here that we can find. Let's see. A little bit of red. Lower. And a little bit we can see. Now let's take a look at some invisible waves with magnets. Cover them up. let's give a wrap. Let's try that again. Lighter. A wrap. A little more. A wrap. You can see the waves starting on the outside. They start to get in line up in here. Of course, right on the magnet, but look farther away from the magnet. The magnetic field has an impact. Invisible. We can't see it. Way up in here. One more time. So magnetic fields, invisible power. So how do we clean up with magnets? We simply put the jar here, give it a fold, and flip it inside. And then there's extra that we spilled. It's easy. Just take the magnet. Oops. You can see it's on there. And then pinch it off. Take the magnets. I see over here on the table. Easy to clean up. Fun with magnets. Invisible.